All right, so the first one I have 2 to the x is greater than 4 to the x minus 1. So these are nice because the 2 and the 4, you can change those so they have the same base. So 2 to the x stays the same, and 4 becomes 2 to the 2 to the x minus 1. So it's 2 to the x is greater than 2 to the 2x minus 2. So if I have 2 to some power, and that's bigger than 2 to another power, doesn't it make sense x has to be greater than 2x minus 2? So x is greater than 2x minus 2. And then we just solve like normal. So subtract the 2x from both sides.
Where did you get, why did 2 go away?
Because if I have 2 to a power is greater than 2 to another power, the first power had to be bigger than the second power, right?
Oh, okay, so you just change out those two.
It's like you took log base 2 of both sides. Okay, so I get negative x is greater than negative 2. I divide by negative 1. So what happens? Yeah, remember I always said red flag. All right, so flip the sign. So I get x is less than 2. Okay, so x is less than 2. If you think about what that is on the number line, you have 2, you have an open circle on 2, and you have everything on the left. So it's negative infinity to positive 2. And then a parenthesis, not a bracket. So that's your answer. Okay. Next one isn't so easy. So when I see that log base 4 of x minus 2 is less than or equal to 3, I know I can change it to exponential form. So I can have 4 to the 3, and then I have x minus 2 on the other side, right? 4 to the third power equals x minus 2. But how do you know where the sign goes? Is it going to be this way, or is it going to be this way? We have no idea. Okay, so when that happens, when you have no idea which way to put it, just put equals and solve for when it's equal. And then we're going to do what we did in the last chapter with critical points. We're going to test on both sides. Okay, so I would have 64, that's 4 to the third, equals x minus 2. So I get x equals 66. So that's going to be on my number line. And I'm going to have either the left or the right side shaded. But with these log equations, so since it was a log, you also need x minus 2 to be greater than 0. So why do I need that? Jasmine, do you know? Yeah, if you take the log of 0, so try that on your calculator. Just do plain log base 10 of 0. What happens? Yeah, it says error, domain. All right, try log of negative 1. Yeah, you can't take the log of a negative number or 0. So basically you need this, you need it to be bigger than 0. So you always have to consider that part too. It's kind of like when we did square roots. Remember when we had something like that, we said the square root part had to be greater than or equal to 0. You couldn't have a negative under the square root. So it's very similar to that. Okay, so when I solve this, I get x has to be greater than 2. So I know I have to be bigger than 2. Anything on the left would give me an error. But I'm not necessarily in the middle. So a lot of people just go ahead and shade the middle because they're used to like the plus minus plus and all that. So you actually do need to test a point. So test a point between. Yeah, so you want to try 10. So 10 gives you log base 4 of 10 minus 2. I want to see if that's less than or equal to 3. So log base 4 of 8, is that less than or equal to 3? So do that on your calculator. Put in log of 8 over log of 4. And see if that's less than or equal to 3. I don't know why my pen does that. It is? What is it? 1.5, yep. So 1.5 is less than or equal to 3. So that means we do shade between. Okay, and then the final step, what about the endpoints? So 2 is what gave you log base 4 of 0, and we know we can't take the log of 0, so that was open, because that doesn't work. And then 66 is what gives you log base 4 of 64. That's actually equal to 3. So since it says less than or equal to, that was the point that actually made it equal to. So it's like that. So it's parentheses 2 to 66 bracket. That's your answer.